Hey guys, welcome back. So it's been a while since I last posted a video update on the TV typewriter, and the reason why is because I've been traveling a lot over the past month or so, and then there were the holidays and just couldn't find the time to actually get to it. So it's been sitting here for about a month or so, and I recently got back to it and tried to debug the issues that I was having with it. And so yeah, this was about mid-January. So right now is January 16th. I started debugging around January 14th or so. But I actually went ahead and fixed the issues that I was having. And I did it all off screen because this was sort of like a intensive effort trying to debug this device. And this is not one of those devices where you can just debug the logic of ICs and things like that. It has other devices and timing, things like that affect the device as a whole. So it's a little bit harder to debug. So I had to do it off screen because of the amount of time it took to debug it. I also posted a question on the Vintage Computer Federation forum. I think it's vcfed.com.org actually. And just questions, or a couple of questions that I had regarding this. If you want to take a look at that, you might find some information helpful. So the issues that we were having, number one was the video output, and the video output, if you remember, was just not very clean. It made like sort of the characters run into each other. I don't know how to explain it, but basically they smeared into each other, and it made it harder for the characters to be actually seen on the screen. So that was issue number one. The other issue was basically some of the characters were incorrect. If I pressed a key on the keyboard, for example, the W here, I would get like a Q or something like that. And a similar issue to that was basically if I typed in a couple of characters, there were certain positions on the screen where the characters were always wrong. Basically, it was just a random character, but it's always the same character, it seems. Well, at least it seemed like the same character, but it was sort of in the same position on the screen every time. We also had a cursor issue. So if I set the cursor to subtract, for example here, I switched this to subtract, and I press the keys, they would actually enter the data or the characters on the screen correctly. But if I set it to add, and I press the keys on the keyboard, the characters on the screen would actually sometimes enter in the correct position, and then actually it would actually enter the character in the correct position, but then it will jump. Sometimes it'll go forward, sometimes it'll go backwards, and sometimes it'll just stay in the same position. So basically, the forward position was acting up for some reason. So that's the other issue. The issue that I was having with the TV typewriter. And the last one, I guess the second to the last, because there's one issue that I'm going to mention right now, which is not a big issue, but I want to fix anyway. But the last issue was this key here. So basically, whenever I press the this @ symbol, we would get an 8. So let's see what I did to actually fix these issues. So I guess we can start with this issue here, which was the @ symbol showing an 8. And the issue with that was actually with the keyboard, and specifically with the jumper wires here. And it's really a bug on the original artwork. The holes here were actually in the wrong positions. Basically, the alignment was not correct. And as you can see here, 2 of these wires are actually crisscrossed, and that's how I actually fixed the issue, by basically removing one of the wires right here and just moving it over to the right, and the one that was there actually move it to the left. And so basically now the @ symbol and the 8 are working correctly. And actually it fixes another issue which we actually didn't see in the previous video, but this key right here, the asterisk and the colon, was actually incorrect as well. I was getting a B for that. So that fixes the issue as well. So the @ and the colon and the asterisk should now work. In fact, I tried all of these keys and they work correctly. So the wires that need to be swapped around are actually jumper wire 25 and 26, counting from the right side. So if you start from here, 1, 2, 3, and keep on going, the 25 and 26 wire need to be swapped around so that the top holes are actually going in different locations, as you can see in the video here. I also made a post about it. Actually, I updated the GitHub README file for this keyboard, and you can kind of see a little bit more info and get a close shot view of the jumper wires. All right, so the next issue was the bad video output and the smearing and all that. And after talking to some amazing folks on the Vintage Computer Federation forum, they suggested that the issue might be actually related to the video out signal right here, pin 20, going to the display that I was using. And it was just something in between there was acting up, maybe the wrong resistance or something like that. So, or maybe the wrong wire that I was using. So I didn't debug this issue yet because I wanted to actually get another wire and try that out. But I actually removed this video out and just used this RF modulator and hooked it up to the TV that I was using. And the characters actually showed up correctly. They didn't smear into each other. So that was a plus sign, but the display was sort of crooked still, and I couldn't. That TV that I was using, that bigger one, I couldn't adjust the screen positioning for some reason. I think it's broken or something. So I put that aside and actually used a different one right here. It's a smaller one. It's a DT505 Datron. It has a smaller screen, and the characters on there actually show up pretty crisp. So the video display issue was actually fixed by just replacing it with a different TV. And a related issue was the characters showing up like on the same position on the screen. We would get like @ symbols or something like that in the same position every time. And that actually turned out to be bad 2524 Signetics shift registers. I had two bad ones, or I guess two faulty ones. They sort of worked sometimes, sort of didn't. So I removed those and installed new ones, and now it actually works correctly. I couldn't find a crystal oscillator for this device that was actually 4.56 1920 megahertz. I just you can't find that anywhere. It's impossible to find. So I guess you could use a close one, like maybe a 4.5 or 4.6. I haven't really tested with the fixes. I haven't tested that yet. But what I actually ended up doing was creating a little daughter board and attaching it to the TV Typewriter timing board. I'll show you right here on the bottom. It's actually the first board, so you can't really see it from the top. But on that daughter board, I installed a programmable oscillator that I got on DigiKey. So whenever you purchase it from DigiKey, which I'll include the details in the description, you can just purchase the programmable oscillator. It's a surface mounted one. I couldn't find a through hole one, so I used a surface mounted one. But whenever you order like on a DigiKey or some other website, you have to specify the frequency that you wanted them to program it for you. So they basically program it for you with the frequency that you specify. So I got that programmable oscillator, soldered it on a daughter board, and attached it to the timing board. That daughter board actually requires power, so we'll have to, you can kind of see it right there. We'll have to give it some power, and I connected the ground to the timing shield hole, wherever, the hole that comes out, they would connect to the crystal oscillator as a shield. That's actually ground as well. And the positive 5 volts can connect to a jumper wire that's nearby the crystal. And then the output of the daughter board actually, I guess where the crystal, where the oscillation would be coming from, would connect to pin, I think it's pin 3 of IC1 of the timing board. I don't know if pin 4 actually would work as well. You can try that as well, but I just tried pin 3, and that seems to work fine. So right now we're getting a correct frequency coming out of the daughter board and going into the timing board. So I am certain that, actually that's the first thing that I did, and I was certain that the issue wasn't the timing, because I was still having the issues that I had reported. So that was the first thing I did. And there's also one other thing that I was having. It was basically, it was related to the wrong character showing up, and I was trying to figure out why I was getting, for example, a D instead of a T. So I hooked up the oscilloscope and on some of these keyboard input pins on the bus, and I think like A4, I believe it was A4, that was just not, not registering on the oscilloscope. So I was trying to figure out what was going on there, and it turns out that actually, because of all the adding and removing boards while debugging the issues that I was having with the TV typewriter, it looks like I might have broken a trace between the top and the bottom connectors. So they basically, the data that was coming from the keyboard was not being transferred all the way to the top, where I guess I had the memory board on top. It wasn't receiving the signal for A4. So I fixed that by soldering a piece of wire to connect them together. And finally, the last issue that I was having was with the cursor board, and that's why it's on top, because that was the last thing that I was debugging. And the issue that we were having, as I mentioned earlier, is if we set the TV typewriter to subtract, the keys would actually be entered backwards correctly. But if we set it to add, the keys would jump. Like if you might enter the key and the character might show up, but then the cursor will stay in the same position, or it might go forward, or it might actually go backwards. So it was really irregular and unpredictable of what it would do. And the way that I debugged this issue is, if we look at the schematic here, the only difference between add and subtract, or forward and backward, is the addition of this C4 capacitor, which is 6200 picofarads. So whenever the switch is set to add, it adds this C4 capacitor into the circuit, basically shorts it together. And it combines C3 and C4, so basically it increases the capacity or capacitance of this circuit. And since it's in line with the signal, what it does is it increases the signal high time. So whenever you add characters, the high time will stay on a little bit longer than whenever you subtract. Basically, whenever you subtract, the signal just drops quickly because the capacitor is just so small. So I just tried to manipulate the value of this C4 to see what was going on, if I can actually change the capacitance and see if it changes anything. And this is why you see this here. It's just a mess here, but what I was doing was basically adding capacitors one at a time to see if it will change anything. And it looks like I got to a certain value that seems to work fine. So now the cursor actually moves forward correctly. And if we calculate the value for this total capacitance here, we get about 50, maybe 52 or 5100 picofarads. So basically, it's lower than 6200 that the schematic specifies here. And I'm not exactly sure if the circuit just needs 5100 or whatever it is. I forget what the exact value is. Or maybe this microcapacitor, the 6200 microcapacitor that I was using, is just not the correct 6200 picofarads. And this can actually happen pretty often with old capacitors. And this is probably the reason why Don Lancaster actually used a microcapacitor, because they tend to be more reliable and more, I guess, they don't drift as much. So yeah, this works right now. This whole setup is a little messy, but it works. But my goal is to actually test the capacitance of this microcapacitor and see what's going on with it, and try to fix that, maybe install a different one. And that's pretty much it with all the issues that we were having. As I mentioned earlier, there is one issue that I wanted to mention, but it's not like a showstopper or anything, but I think it's something that we would like to fix. And the issue is with this diode right here, the 12 volt diode. sort of gets pretty hot whenever we run the TV typewriter. So the solution that I was thinking of is to basically replace it with like a 2 watt or something like that, somewhere around there. Right now it's a 1 watt, so I might replace it with the 2 watt and see if it changes anything. All right, let's go ahead and see the TV typewriter in action. So let's go ahead and power it on with the switch. It might be a little hard to read right now since the screen is so small, but I am seeing quite a bit of characters, which are actually the @ symbols. The screen is sort of shifted to the right and down. I guess we can adjust the jumpers on the TV typewriter to change the position of the video a little bit. I haven't played with it that much. Another option is to actually adjust the back of the TV to make it correct. But unfortunately, this TV doesn't really have many options for adjustment on the back, so we'll just have to stick with that. Okay, so let's go ahead and clear the screen. I have the switch set to subtract, I guess. Let's see what happens if we type in some characters. Yeah, so it's going backwards, as you can see. I'm just typing just random characters. Let me change it to add and clear the screen. And let's try to type something in. All right, so I just typed in, hello, this is a test of Don Lancaster's TV typewriter, and it actually shows pretty well. Let's just do some tests here to make sure that all of these switches actually work. So we already did the add and subtract switch. What about the cursor on and off? So I'm going to turn it off right now. So the cursor is off, and we can still type and enter characters in, but the cursor just won't display. I'm going to go ahead and turn it back on. The next switch is the clear screen, which we know that it works because we already used it. And then there's this repeat switch, and the way it works is like if you press a key down, you can just press the repeat key switch here to repeat that key that is being pressed. So for example, if I press the key, K key, and I can toggle the repeat, it will repeat K as many times as you want. The next switch is the change and keep. Right now it's set to change, which is why we're able to enter characters on the screen. But if I switch it to keep, regardless of which character you press, it'll just basically skip over it. So let me change it to subtract so we can get a better demonstration. So for example, I'm just pressing random characters, and it's just skipping over the K and leaving the K in place. So I'm going to change it back to keep and make it go forward. Then there's the page A and page B. I can switch it to page B, and it's going to be just nothing because we don't have a page B. I'll switch it back to page A. And finally, there's the the line and full switch. And honestly, I don't even know what this does. I've tried it, and it doesn't make a difference. Like, I really need to look into this still. I'm not exactly sure what it does. But I think all the other switch I'm pretty confident with. I'm not sure if this switch is actually even useful, so we'll just leave it like that for now. Okay, so I'm actually very happy with this project so far. It was a little bit tough to debug, but I'm glad with the way it turned out. So I guess the next thing that I want to do is insert into an enclosure, including the keyboard, and make it basically a nice little enclosure for it that we can use for displaying data on a screen, and maybe even hook it up to the Mark 8. The enclosure that I'm going to be using is this box that I got on, I think, in DigiKey. It's 17 by 10 by 5 inches, and I already made markings for the keyboard, and I cut the keyboard markings out with a Dremel tool. It's not very pretty, but it will do for now. And then I inserted the keyboard into it. As you can see, I drilled some holes for the screws and attached the keyboard. And the keyboard attaches from underneath, and you have the encoder right under the keyboard, as you can see here. Then I made some markings for the switches and drilled some pilot holes. And I used a Dremel tool to cut those holes out. And unfortunately, I kind of scratched up the enclosure a little bit while doing it. But my plan in the future is to actually add a little label on top with all the, I guess, all the labels, so it's going to cover it up. I then proceeded to install the TV typewriter PCBs into the enclosure, and I had to actually unsolder the switches because I had to insert the switches through the top, so I had to resolder it, and this process was a little bit time consuming and tedious. I then proceeded to attach the typewriter to the enclosure using some screws and using the existing holes on the PCB, the mainframe PCB. And then I inserted the video out through the back, made a hole for that, and also made a hole for the power cable. Before attaching the switches, I actually made sure that they were oriented the right way, so I basically turned it on and did some testing for that. Once I was confident with their orientation, I went ahead and mounted them with some screws. In the next step, I removed some of the protective adhesive to mount the video out and also the power cable gland, and inserted the power cable into the gland and then attached all the wires together, the high power lines together, and clean it up a little bit. And now that I was done with the work inside the enclosure, I went ahead and removed the remaining protective adhesive from the enclosure. For the labels, I actually used some Letraset labels that I got on eBay for another project. This will be, I think, will be temporary for now. But basically, you just apply it to the surface and just press it down with a sharp edge, or semi-sharp edge, and it sticks to the surface. It doesn't stick too well to metal unless we protect it with something else on top. As you can see, some of the label was removed while I was cleaning the enclosure. I also added some cedar wood panels on the sides, and as you can see, they're sort of at an angle from top to bottom, and that's how the original was made as well. And I also added the TV typewriter text on the front of the enclosure. On the back of the enclosure, we have the power line coming in and a video out. We also have the antenna wire coming from underneath the enclosure. I think in the future I'll actually add some connectors for that on the back of the enclosure for that, along with some other components, which I'll probably mention in the future. But I think it looks pretty good so far. As a reminder, I still have the PCB sets available for sale at callenchuk.com if anybody's interested in building the TV typewriter. It comes with the mainframe, the memory board, the timing board, and a cursor board. And additionally, there are some boards available on the website for the keyboard. And also so this one actually comes with, this one is the modern version. There's also the original version for the original key stems. And also the encoder, as you can see here, this encoder actually has the silk screen on it, and it attaches to the keyboard on the right side. Those are available for sale at callenchuk.com if anyone's interested. Additionally, I have some 2524V Signetic shift registers available. There's just a couple of sets left, so make sure you get some if you need some, because these are really hard to find, and I am almost out. Okay, so I got the TV on, and I also hooked up the monitor and connected it to the TV typewriter, because I think I figured out the issue that I was having with the text smearing, and it was actually related with the monitor itself. Basically, the contrast button was broken, so I had to play with it a little bit to actually get it to show up correctly. So let's go ahead and turn it on. Moment of truth. Okay, so we're getting a display back on both the TV via the RF modulator and the video output. So let's try to clear the screen by pressing the clear screen button. Perfect. And you might notice right now that we don't see the cursor, and that's because the cursor button is switched off. So I'm going to go ahead and turn it on. I have the switch set to right, so basically the text will actually be entered going right. It's set to change, and it's set to memory or page A, so we can actually start typing. So let's try to type something in. And it looks like I made a mistake. So the way to fix that is we have to switch the change key button to keep, and then go switch the left and right button to left, and we can just go back by pressing any key, and it'll just move the cursor backwards, and then we can change it back to right, to enter data to the right, and change it the change keep to change, and then we can start typing again. So let's fix that mistake. Awesome. I like how crisp the video output is on the monitor. You can't really see it on the video because of frame rate issues or differences, but it's actually pretty crisp. The TV output is pretty good as well, although it's not as crisp, and I think it's probably just due to the TV that I'm using. It's I can't really adjust it that much. Those buttons on the right side, the contrast and brightness, they don't seem to work, so I think it's broken. Let's try switching to page B. Yeah, so with page B we have no data on the page, so let's try to clear the screen. And as you can see, the cursor went back to the top there and top left, but the screen was not cleared, and that's because we don't have page B memory installed. So I'm going to go ahead and switch it to page A again. And the cursor remained up top. And by the way, we can actually turn it off by switching the cursor switch down. And now we don't have a cursor, but you can still type into it without the cursor. But I'm going to go ahead and turn it back on. So it looks like the TV typewriter actually works pretty well. Let me actually type in something else into the TV typewriter. Basically, whatever we see on the magazine here of the Radio Electronics magazine. So basically, build this TV typewriter and display messages on your set screen. I'm going to type that in and see what it looks like. I hope you enjoyed watching this video. Please hit the like button if you found this video interesting. And also don't forget to subscribe because there are some really cool videos coming up soon and I don't want you to miss them. Bye-bye.